Alright, so we've looked at how we simplify algebraic expressions involving algebraic fractions. Now, what about solving equations where we have algebraic fractions involved? Let's take a look at this first example. If we want to solve this particular equation, we need to first of all identify what processes are being done here and how do we go about undoing these. So this involves the process of transposition. Now if we look carefully, we see that we want to solve the equation for our unknown n, which is in the numerator here. We have 3n plus 4 over 5 is equal to 5. And what we want to do, there are a couple ways in which you can go about solving this particular equation. However, both ways will still essentially boil down to the same principle behind why you are doing what you're doing, and that is to say, if we look carefully here, in order for us to make n the subject, we actually have to eliminate this division by 5 here first. And one way of doing that is by multiplying both sides of our equation by 5. So if I were to multiply everything on the left by 5, as well as everything on the right by 5, this will help me eliminate this division by 5 on the left-hand side of the equation, and I'll remain with 3n plus 4 on the left-hand side, and on the right, the product of 5 and 5 will leave me with 25. Now from here we have a linear equation, and to solve for n, we simply transpose for n from here. And this will involve subtracting 4 from both sides of the equation. This will leave me with 3n on the left and 21 on the right. Finally, to solve for n, we'll divide both sides by 3, and this will leave me with n is equal to 7. So this utilizes the concept of the equation being like a scale, keeping it in balance. What we do to one side, we must do to the other. There's also the notion of the cross multiplication, which it utilizes the same principle, but in other words, it's more like a shortcut to get to the simplified statement. So if I were to apply the concept of cross multiplication here, what I would have gotten would be something like this. I first start off with my original equation, 3n plus 4 over 5 is equal to 5. And what I do is my expression on the right side, it's just a single numeral. I can express this whole number as a fraction where its denominator is 1. Now the concept of cross multiplication means that I'm going to multiply opposite numerator with denominator. And in this case, this means I'm going to multiply my numerator of 3n plus 4 by the denominator of 1. And then I'm going to multiply my denominator of 5 across here with my numerator of 5. This will make everything nice and linear now, because I won't have any division by anything. And what I'll have in the next line will be 3n plus 4 is equal to 25. Now some people may say, well, this was much easier, why didn't you just do this from the beginning? The concept here is still utilizing the principle of keeping the equation balanced and undoing operations so that you are still making n the subject. It's just a different way in which you can approach it, a shortcut way as I would call it. And from here, what I do to make n the subject, it's going to boil down to being the same procedure, where I subtract 4 from both sides, so I remain with 3n on the left side, and 25 take away 4 on the right. Next, I'm going to divide both sides by 3 because I want to solve for n. So that will leave me with n being 7. So both ways will still give us the same answer. It's just a different way of referring to the process itself. So this is how you approach solving an equation involving an algebraic fraction.